In this session, I will tell you how to solve problem using instantaneous center of rotation method. So problem is here. An engine crankshaft drives a reciprocating pump through a mechanism as shown in the figure. I will show you figure later on. The crank rotates in the clockwise direction at 160 rpm. The diameter of the pump piston at F is 200 mm. Dimensions of the various links are OA is 170 mm, CD is 1 CD is also 170 mm, AB is 660 mm, D is 830, BC is 510. For the position of the crank shown in the diagram, determine the velocity of the crosshead E, velocity of rubbing at pins A, B, C and D, and the diameters being 40, 30, 30 and 50 mm respectively. Torque required at the shaft O to overcome the pressure of this 300 kilonewton per meter square at the pump piston. So this you can see the configuration diagram. To, to draw this configuration diagram, first of all you need to mark a point O on the sheet and then draw a line OA at 45 degree to the x-axis. Then you move 480 mm from O towards leftward. At the same time, you can move 660 mm downward to locate point C. How it has been done? Let us look at here. So first of all, mark the point O. So this is point O. Then from O, draw a line of 45-degree angle. Draw a line. So this line you have made, and that you can call it as a OA, and this is making an angle 45 degree with the x-axis. Then you move downward from this point. How much downward? That is 660 mm, right? And then you can move this side 480 mm. So after moving 480 mm, let's say this is the point which you can locate at 480 mm. Then you get the point C, right? So it's C, and now you have A. Now you can look at the AB length is 660 mm. So from A, mark a arc of 660 mm. Let's say this 660 mm arc is cutting over here, and from C, take a arc of length BC, that is nothing but 510 mm. So take a arc from this. Let's say this is intersecting over here. Now you can join these 2 points. You can join these 2 points by a straight line. Now from C, draw a line of length 170 mm. So you will get CD. So this is the point D. Now this, you can say BCD is a bell crank lever, and then join A and B. Join A and B by straight line. So you join these 2 points by straight line. So now you can make this as a bell crank lever. So this one is your bell crank lever. Goes like this, right? And now here you can have the fixed link. Now at the same time in the problem it is mentioned with reference to this point C, the path of the crosshead is at 120 mm below than this line. So this distance is also given in the problem, 120. So I can move 120 mm downward, and then from bell crank lever this point, the distance D is 830 mm. So mark a arc of 830 mm. So let's say this is cutting somewhere here. So join these 2 points by straight line, right? So you need to join these 2 points. Say this is the point D. So now this point becomes point E, and the slider is here. This is point G. Now I can give the name to the different links. So the first link is the ground. crank is link number 2, and this one is the link number 3, and this one is link number 4, and this one is link number 5, and this one is link number 6. So as you can see, there are 6 number of links. So there are 15 numbers of eye centers. So what are those eye centers? We can use bookkeeping method to label those eye centers. 1, 2, 3, 4, 5, and 6. So 1, 2 is one eye center. 1, 3 is another. 1, 4, 1, 5, 1, 6. 2, 3, 2, 4, 2, 5, and 2, 6. 3, 4, 3, 5, 3, 6. 4, 5, 4, 6, and 5, 6. So these are the 15 different eye centers which are possible. Now locate some of the eye centers which you can locate by observation. So this is one eye center you can locate, 1, 2. This is another eye center you can locate, that is 2, 3. This is another eye center you can locate, that is 3, 4. And this eye center is 0, 1, 4. And this eye center is between 4 and 5. So this is 0, 4, 5. Right? Now this one is eye center between 5 and 6. So this becomes 0, 5, 6. And as this slider 6 is moving on a straight path, so this link is nothing but 016 at infinity. 016 will lie at the infinity, so that we can locate by this way. So there are 1, 2, 3, 4, 5, 6, and 7. 7 number of eye centers we can locate easily by observation. And to locate unknown eye center, what we need to do, we need to draw a circle and divide this circle into equal number of parts as number of links you have. So the answer is there are 6 number of links, so I can divide it into 6 parts. Then I can join by solid line if eye center is known to me. So these eye centers are known to me, so I am joining it by solid line. 1, 2, 2, 3, 3, 4, 4, 5, 4, 5, 5, 6, and 1, 6. At the same time, I also know 1, 4. So I am joining it by solid line 1 and 4 as well. Now, by doing so, we can completed the half part of the problem, that we can, by observation we can find out eye centers which are possible, and the remaining eye center can be done using detailed methodology, or you can say Kennedy theorem, that I will explain in my next video. All the best.